So take it away, Daniel.
Okay, so hello everyone. As Jaap said, my name is Daniel Silva, and I'm here today to present you PowerShell Core on the Raspberry. First of all, I'd like to thank everyone for showing up and taking your time, and especially to the organization. So going ahead, I can leave the camera here for now. As about me, I'm a software developer, mainly focusing on .NET Core, Entity Framework Core, and SQL Server. When I'm not on work, I do some projects with my Raspberry, including now, most recently, projects running PowerShell, which is I'll be showing you here today. Other than that, not so much, but I still like to do some gaming. Unfortunately, I don't have much of the time, and I have other interests. So other than the places that I'm showing you below, that you contact me, like the Twitter, the GitHub, and my blog, you can find me on Slack on the SQL community, the PowerShell and the ASP.NET Core, and latest, which I forgot to add here, your user group. So moving to the agenda, let's see what we'll be covering here today. We'll starting by the basics, which is what's a Raspberry Pi. We will also see the specifications for the module that for the version that I'll be showing you here today. We'll see how is it possible to run PowerShell on a Raspberry. I'll demonstrate you how easy it is to set up the PowerShell and do some testings. Then I'll be showing you the IoT module, which is a module developed by Microsoft in order to allow interaction between the hardware and the PowerShell codes. Then I'll show you an example that the module that I start developing using the IoT module as a base. And for last, we'll see how to debug a script that is currently running on the Raspberry. So what is a Raspberry? Yeah, I don't know if you have the camera on your screen, but if you do so, you can see here a Raspberry.
Camera is turned on.
Sorry? You're showing it?
Camera is turned on. Yep, we can see it.
So here is a Raspberry Pi. It's a tiny little computer. It's a single board computer that basically has the capability of running a full operating system. It has been developed in the UK by the Raspberry Pi Foundation. There are lots of modules of boards, but mainly we have the Raspberry Pi 3B, which now has the 3B Plus module, and the Raspberry Pi Zero W. For comparison, I do have both. I have here Raspberry Pi Zero W, which is smaller and also weaker in specifications against the Raspberry Pi 3B, but is also an excellent board to have, although this one cannot run PowerShell yet, and I'll explain you why later. But the main purpose of the Raspberry Pi Foundation is that they've designed these computers to allow people to interact around the globe or easily have access to a computer and to help the young people to start programming. They have lots of projects and a lot of community help to start to help the young children to program. A fun fact that I found out when I was starting or preparing this presentation was that by March 14 of this year, which is also the Pi Day, because the 3/14, they have sold 19 million Raspberries, and from all of those 9 million were the P3B module. By this day, they have also launched the newest module, the newest board, which is the 3B Plus, which is basically almost the same as the 3B, but with some improvements. So just so that you get an idea, we have the P0W on the left, the 3B on the right, which is the one that I'll be using during this presentation, but they also have the model 1, the model 1A, 1B, 2A, 2B, and then they've skipped to 3B and 3B plus, other than the 0 module, which is the 0, 1.3 and the 0W that already includes Wi-Fi. Talking about what it does include, we have the specifications here. It has more specifications, but here we'll be focusing basically on the quad-core processor, the 1 gig of RAM. It also has a 40-pin GPIO pins, which are general purpose inputs-outputs, which is these small pins here that are used to attach some hardware and allow the interaction between the hardware and the software. We also have a micro SD port, which is the port that we use to store our data and to have our operating system. Just to give a little bit of context, why the Raspberry Pi? Why have I started to mess around with Raspberry? Basically, it goes down to like 2 or 3 years ago when Microsoft made IoT Lab that I think it was around all the globe or all the world. And it also passed on Lisbon, which is where I'm from. And I've attended to it. Basically, we did some simple things like attaching a sensor, gathering some data from that sensor and send it to Azure, and then process that information. I got really interested in this tiny board, and when I went home, I've started to research what projects that people were doing, and basically I've done the most common projects, which started by a little arcade box or arcade console, if you want to call it. This is basically as you can see here, if I can, okay. Here is a board that attach all the buttons that we have, all the buttons that we have here and the joystick. And basically that connects through a USB to the Raspberry and emulates a controller. Then you just simply flash an image to the Raspberry, load up the games that you want, and you are ready to play like an old arcade console. Other than that, I've done another gaming project, which was basically you can call an evolution, which is a controller, a Bluetooth controller that is holding a power bank, a Raspberry Pi, and a 5-inch screen. So basically this is remote. Forget the cable here because this was charging the controller. And this allows me to make some portable gaming when I go for example, for a travel. It does not require internet connection. All you have to do is simply boot the Raspberry, turn the controller on, and you are ready to go. Then a little bit different, and this one is a project that I've also made, but this one wasn't for me. It was a gift. I've decided to do a digital frame using a screen and some LEDs, and other than that, the Raspberry Pi 0W. So the whole concept here was to have a digital frame running, having a digital frame that was powered by a Raspberry, which was running Kodi and had some images showing as a slideshow. The trick here is that I've an implementation of my own cloud, and I have a Raspberry Pi 3B holding that cloud. And what I allow to do is that the people or whoever wants to send images to the Raspberry, or in this case, the digital frame, upload the image to a specific folder on the cloud, and then the image are displayed here. This allows me to not having like, can you please change the pictures here? I'm tired of this one. You can simply just add the image that you want, remove those that you don't want, and basically the final results after putting all in a box and doing some painting became something like this. Although the LEDs are RGB, it's mainly used for white to give some ambience. But this is not the topic here. The topic is PowerShell, so let's get back to it. How is it possible to run PowerShell on this little computer? As you've seen, it has only 1 gig of RAM and a 1.2 quad-core processor, although we know that PowerShell does not require that much. So the trick here, or not the trick, but the background here is that until recently, we only had PowerShell, which was based on the .NET. And until like, I don't want to be wrong, but like 3 or 4 years ago, at least publicly, we only had the .NET framework, which powered our Windows PowerShell. And as the name implies, Windows means that it will only run on Windows. Then Microsoft made a really smart and good move and became open source and cross-platform. And that allowed them to have the .NET Core, which is a cross-platform and open source project for the .NET. And as I said above, and as you might know, we have PowerShell is powered by .NET. So in this case, .NET Core gives power to the PowerShell Core. And I'm not trying to make some point saying power and PowerShell. It was by mistake. But this then allows us to have PowerShell running on on different operating systems, such as a Mac, Linux, and Windows. Even inside the ecosystems, these ecosystems, for example, on Linux, not every system is able to run it, but actually it's not due to the system. It's mostly due to the system architecture. As you might remember, I said that the Raspberry Pi Zero-W is not able to run PowerShell Core. This is not because, Raspberry Pi Zero-W does run Linux operating system, but it has a different set of architecture, CPU architecture. So this means while the Raspberry Pi 3B has IRM v7, which is supported by the .NET Core, sorry, the IRM v6 is not. So the limitation, the reason why PowerShell Core does not run on Raspberry Pi Zero-W is not because of PowerShell itself, it's because the .NET Core. And the reason why it does not run on .NET Core is because of the JIT compiler, which is not prepared to run IRM v6 instructions. So enough talking. Let's just see how can we set up the PowerShell on a Raspberry. Here I'll need you to pay attention because this is a really long process and hard process. I'll try to be as quick as I can, but things take their time. So we can start by going to their GitHub, or as Microsoft says, it says now it's GitHub. So I don't know how it's pronounced. I'll keep saying GitHub. And if you scroll down, they have a lot of documentation here. And when we scroll down, we can see here the installation for Raspbian Scratch, which is the operating system that we are running. And you can see here that we have an experimental version. We have the stable version, which is the PowerShell 6.0.2, and the preview version, which is the 6.1. I've tested all my things with both systems, but as the name implies here, the stable, I'll stick with the 6.0.2. And here you can see a lot of documentation. This does not take much, but I'll just guide you here. Just to give a little bit of context, here I opened the terminal and I've connected to my Raspberry. So we can see that we are running on Raspbian, the Scratch version, and we are located in a folder called presentation. I could download the whole PowerShell, it does not have much of space, but in order to avoid some internet lags and lag to the presentation, if we list the files here, we can see that we have the PowerShell here already. So I'll simply start by creating a folder to hold all of our binaries. Oops, it's mkdir, and this one is together. So let's start by extracting the tar file. The tar file is like a zip file, but on Linux. So we simply say tar, and we say that we want to extract the PowerShell folder and copy the output to our PowerShell folder. After extracting, we can see here that we have some names that we all know, like system.reflection, system.io, and we can see here a PWSH DLL. But if we simply change to the folder that we just used to extract, and this lagged a little bit, it's stuck. Hello? Okay, well, if we list the files here again, we can see among all the colors, we can see like a PWSH file here. So I have to do the PWSH here, and I have to use the dots because I need to say that I'm running on the local folder. And here you can see that we have PowerShell version 6.0.2, like I told you. And if you didn't fall asleep, because this took a lot of time, as you could see, we already have PowerShell running on our Raspberry. So in order to prove you so, if you are still doubting about it, you might know this variable here. We have a version table, and we're running the 6.0.2 running on Linux. Here it does not specify that is the Raspbian or which version of Linux of Raspbian is running. It simply say the generic type of like 4.14. And with this, we already have PowerShell running. So if I exit, and just to end what I was telling about the PWSH, if I do PWSH here, the bash is telling me no command not found. So although I'm in the directory, I need to specify that with the dot that I'm on. I want to execute what's currently on this directory. Same goes if I go to the change directory and do PWSH here. So I cannot run PowerShell unless I specify the directory. And now you might be saying, "Oh, really? That's really bad. Why do you have to do that?" Well, it's basically like how we do on Windows. When you want to run a command from the terminal and you don't specify the path, it will say that you cannot run the program. So the equivalent to path on Windows is a command called link or ln here, and I'll simply copy to avoid more errors. I don't know if you're seeing this, but I just want to remove this. Okay. So by doing this, I'm saying like link what's in this file, which is the PWSH, and create the link on our user bin PWSH. So if I do a copy and a list of this folder, we can see here somewhere like PW. Well, you'll have to believe me that it's here, PWSH. So again, I'm outside the PowerShell folder, and now if I do PWSH, I can simply run PowerShell. So this allows me to run PowerShell wherever I am in the terminal. So let's just get back here for a second, and moving up next, and because this might be the reason why some of you are still out there. What if I told you, or what if I tell you, that with your PowerShell knowledge, you can use your knowledge to interact with some hardware? So basically that's it. What I'm telling here is that with your PowerShell knowledge and without knowing anything about some specific bits or bytes or how to connect some circuits and whatnot, you can use your PowerShell skills to do some awesome things, like I'll be showing you here. Some of the trick, or not a trick, but if you remember, I told you about the IoT module, which is a module that has been developed by Microsoft. And what they did was something that was really smart. Instead of trying to reinvent the wheel, they've used some code that was already existing. And so basically, they've created a module, as I told you already, which is called the PowerShell IoT, which runs or relies on the .NET Core because it's PowerShell. But then they wrapped another library, which is called the Raspberry IO, which is a .NET API that has been designed by the Raspberry IO. I don't know if you can call them a group or a set of people, and it's a project. And their objective is to make the C# a first-class citizen, where it's dominated mainly by Python's code. So if you are any familiar with Raspberry, you'll find that almost anything that you want to do will have Python scripts somewhere telling you, like, interact with this using this Python script. You want to do that action, use this Python script. And their objective was to allow people to use C#, because some people like me, I don't know Python, and this was a bottleneck for me because I didn't have time to learn Python. And some of the projects, I know that if I could use the C#, I could do what I wanted to do. So this project is really interesting, so you should definitely check it out. But basically, this one also depends or relies on .NET Core. This was not true until .NET Core was out. So this project exists even before the .NET Core. In order to allow the usage of C# anyway, they've relied on Mono project. So when they've migrated to .NET Core, Microsoft made the move to implement a module that relies on this one, because both of them use the .NET Core. But this one also wraps another library, which is a library called Wiring Pi. It's a C library, which basically manages all the low-level codes to interact between the hardware and the software. So basically, we have here a set of layers. Going from the bottom, we have the C library, which interacts between the hardware code and the software. Then we have a project that wraps this one, and we have a PowerShell module that wraps another one. And if you remember that I mentioned that I'll be showing you a module that I've developed, that module is called the scroll hat module. And basically what I've done is I've added yet another layer and have my module that depends on the PowerShell IoT core module. So let's jump again to the codes, and just so that you don't get lost, and you heard me saying like scroll hat, and what is that? What is the scroll hat? Just so you have an idea, this basically this small piece of hardware, which is basically has a matrix of 11 per 5 LEDs, which gives a total of 55 LEDs. And the LEDs can be light independently, but the whole matrix controls the brightness. So you can simply set the brightness independently for each LED. But before going to that one, let's see here the PowerShell IoT module. So basically, then again, we have a whole set of documentation here and how to install it, how to compile it from source, some examples. And since this is on GitHub and it is open source, as you might be able to see here, you are allowed to contribute with some code or some examples. In this case, I've contributed with an example for this module. So you can show the world some examples that you had implemented. We can see here some weird names like PM and other things. These are basically some LEDs. In this one, you have a pressure plus temperature plus humidity. So with this piece of code, you simply have a temperature, a pressure, and the humidity. I saw before you say, or before you think that, yeah, but the IoT has no usage on the real world or some on production levels. I saw a blog post Unfortunately, I forgot to link that on my presentation, but I can do that later. Which was someone was having problems on their server, and basically the server was getting too hot. So what he decided to do was simply to attach this sensor, put it on the Raspberry on that room, and with some PowerShell codes, it takes the temperature, and from time to time it takes the temperature, and if the temperature is higher than the threshold, it simply sends an email saying something like it's too hot here. So let's just go to what we need to do. I'll just copy here the install module, and I'll run PowerShell here with sudo, and I'll, in the moment, or I can tell you now, I'll be running here with sudo, because when you want to interact with hardware, even on Linux or even outside the PowerShell, you need higher privileges. So since I'll be running on this console, I'll already run with sudo, and it will take some moments to prompt me if I want to trust this repository. But yeah, then again, showing up here, you even have some ways to move your code to the Raspberry, some shortcuts, and as they say here, the objective here is to do something as simple as you say set lights on, and on the background what it does is set a pin with the value high. This is basically what we'll be seeing in a moment, not with the GPIO, but with other interface. And I'll just allow here. This will be installing, and we might be ready. Okay, so now let's see what do we have here. Let's use our get commands, and the module is the IoT one. So here we have 3 gets and 2 sets and 1 send. So basically, as they state here, once again, they want to have a module to interact hardware using the most common protocols, which are the GPIO, or the general purpose input-output, the I2C, and the SPI. Mainly, I'll be focusing here on the I2C protocol, but later I have an example with the GPIO. So I'll be focusing with the I2C because it's the one that that little hardware that I've mentioned uses. So here we have the I2C device and the set register and get register. How does this work with the I2C protocol? It's pretty simple. Basically, it works by a set of registers which hold some data. So you have a device, each device has an address, and each register also has an address and a value. So basically you say, I want to set on the register 1, the value 2, and you use this command to do so. Yep, is the camera on, or have you removed that?
Yeah, the camera is turned on. You can go.
Okay, so basically this is the very same piece that I've showed you. Is the LEDs are here, and if you can see this pretty bad soldering, is because it was soldered by me. So this was some small challenge because I had no knowledge on how to solder. But I'll just simply set this one here if I can. Okay, I'll just remove the P0W from here. And once again, as I told you, you can just, I already have the files here, but in order to use the module that I've developed, I've called it this weird name, the IS31, etc., because it's the name of the chip that this uses. So although I've not tested and I've not ever seen other usage for this chip, the module that I've developed here should also work with any other chip that is the same as this one. So we have here a pretty basic GitHub page with some README where I'll show you how to get started and what is available so far. This is not fully updated. And we have here an example of what we'll be seeing. So moving back to our Raspberry, we already have here the folder or the project. So when I'm here, I can simply do an import module, and I want to import my scroll phead PSM1. Okay, so let's take the same approach as we did before, and let's use a get command to see what we have available. Scroll. Okay. We have here a bunch of functions, but basically what we'll be focusing here are those sets, which are basically to set the brightness, set some crazy LEDs, which I'll be showing you, turn all the LEDs off, and write a simple char or write a string. So what you'll be seeing here, and by importing the module, I can already do something like write string or write phead string, and we can write our hello world, because it's basically the first thing that we do with everything we start, right? So you probably have seen an hello world on the bottom right. And if you have not, I can say that I want it to iterate like 3 times, and it just throws me an error. I mean iterations. Why not using tab completion when you can? So as you are seeing here, it has some text and it's scrolling. The scrolling part has been a real challenge, but basically, let me just grab here a pen. Basically what I've done is that you have 11 registers here, and each time you write a column. So, sorry, I think I said registers, you have 11 columns. Each iteration you write the column, so each column is a register. So basically, after writing the 11 registers, if you have something more to write, you need to shift everything. So basically what I've done was that after writing the 11 registers, I've shifted everything and removed the first part of the list, because the registers are on the list. And as I told you, you don't need to know anything about or anything specific about electronics. You can see the data sheet for this module, and basically you can end up with something like this. So I'll be showing here the module. This is after some development, of course. I want to remove these parts. But basically, what we do have here is like the crazy LEDs function. You have the write char and write the string. And if you might be wondering why as I told you, you have to set the device that you want to use. That is done here by doing this select scroll phead. Each device has an address. In this case, in hexadecimal is 60. It has a configuration address and a configuration value. So basically, this is always paired between the device and between the register and the value. So what I'm doing here is that I'm getting the device with the get device commandlet. I say that the ID is the address that is specified on the datasheet, and I want to set the register which has the address of the configuration register. This is also on the datasheet. In this case, the address with 0, and basically this value is the configuration that I want to use. In this case, is to do something like, if I'm not mistaken, is that use the full matrix and turn off the audio, because this has some pulse audio modulation setting, which I don't know what that is. But as you can see, you don't see here anything as low level as a C code or anything like that. For example, the brightness function is quite simple. I simply have parameters saying that when you want to set the brightness, you have to specify the intensity. And I have mapped basically all the string values to some bits. These bits are the configuration on the register, which once again is on the data sheet. I've displayed them here on binary in order to be easier for me to write them and to interpret them. And after that, what we need to do is once again set the register, saying that the address is the address of the lightning effect address, which is the 0D, and the value is the value that is mapped on this array, or on this hash map, sorry. So basically we do have here again all the function for the write a string. Writing a string is basically writing a set of shards, and on the set write the shards, basically we need to get a letter which is right up, that I'll show you in a moment. We basically say iterate over that and say for each of the register value, write that. And basically the trick here is to have a whole hash map here saying that the letter A has the 3 and E, the 0, 5 and the 3E. So how can you get to these values? What have I done to get to these values? So if I turn again all the LEDs off, okay. As you might have noticed, I have a simple setup file here. If I do run, or if I show what's on that file, and I'll show you here because it's easier. We have colors and things. Again, we have the address, and the interesting part here is this one. So basically, as I said, each column is a register. And if you want to light LEDs, this is binary. So you have here, if you do see here, you have a bit, 4 bits here, which make a byte. And here you have the beginning of other bytes. So say that you want to write, as you can see here, we are trying to write the letter A. And if you do know binary, or if you don't know and you want to learn, this is a cool way to do so. We have here that the first bit has no value and all the other 3 bits have value. So this will match the letter E. And then again, we have the first bit on the second byte on, so we want to write 1 here. And if we do have to write, in this case, to make the middle of the A letter, you want to write the LED 1 and the LED on the position 3, which stands for 4 plus 1, which makes 5. And so on the second register, you see here the 5, and so on. So after some moments, I wrote the whole alphabet. I can still write all the alphabets on lowercase, and I need also to have something like hashtags and some other characters that might be interesting, like the double dot, a comma, and things like that. So basically with this, you have a full module, or not totally implemented yet, but you can start doing some awesome things, like since this allows pipelining, you can do something like, okay, so in this case, I'll just type it, but you can get from, for example, the Spotify API, and you want to say something like now listening, and you want to say something like, I like Stone Sour, so Stone Sour, and the music can be this one. And if you pipe that to the right p-hat string, you'll probably, you'll see some errors here. As I said, oh, and I want to, okay, let me make this run forever. As I've told you, the scrolling is a bit of a challenge. So the errors that you see here at the beginning is because of the first iteration of the scrolling. This does not happen with every letter, but it's something that I have to correct. But you should be seeing here that you have basically the now playing song, and scrolling here. Other thing that you can do if you think that's too fast or too slow, and in this case, so that we can see, I'll just write that with smaller text. And let's say it won't forever. And we want to wait, for example, 200 milliseconds. Here is a lot slower. And if you think that's fast enough, you can say something like, oops, I'm losing my, let me just clear this one. You can say something like, okay, write one for each second. So basically, here you can see, as you can see, the scrolling is like move every register at the time. So this produces an effect like it's throwing them. Let me just get some water here. So for example, as you have seen, I have bugs on my code. Everyone has. If you think you don't have, you just haven't explored enough. But as I was telling you before, oops, my computer sometimes is a little bit slow and okay. You can debug a script that is running on the Raspberry, which is what I'll be doing now. So once again, I'll be using, this is documented. Again, it's on the PowerShell IoT module, but you can easily find that information. So you have here a whole set of how you can just debug things. But again, I'll do my way, or which is based on the way that they've shown. But here I had a small problem. So I'll just exit PowerShell here and exit, please. Okay. So what I'll be doing here is that I will purge the OpenSSH server and install it again. The reason why I'm doing this is because after a fresh install, there's a step on this guide that requires you to restart the service. And when I've done a fresh install on the Raspbian, I've tried to follow these steps, and I was having an error saying that cannot start the service. And when I tried to install the service, it was telling me that the service was already installed. So it was a little bit of a mess. And after some research, I've seen someone saying that if you purge and you install again, it solves, and it does, basically because purging removes all the configuration files. So here it will be installing the SSH server. It will generate new keys, and we'll be able to do our remoting, hopefully. So it will be okay, saying that it's installing. Oh, and by the way, this will only work between PowerShell Core sessions, which means that if you try to use these methods from PowerShell Core version or a PowerShell Core script to Windows PowerShell, it will not work. And this is because Windows PowerShell does not support remoting via SSH, and the .NET Core does. Sorry, the PowerShell Core does. Basically what we'll be doing here, and that's what I'll be doing right now, is that we'll be adding a subsystem to our SSH server, and we want to passwords here, not this one, but here. So basically I'm removing this comment here, saying that we now allow password authentications, and scrolling to the bottom, we can find here that we want to use this part, which is create a subsystem for PowerShell and run it with sudo pwsh. Notice that again, we need to run it with sudo because we'll be interacting with hardware. And if you don't have the sudo, the whole thing will just explode. So after saving this one, and this is the part that's got my crash with the fresh installation, I can restart the service, and now hopefully we can do our debugging. So in order to do our debugging, we'll be running VS Codes and the PowerShell extension. This is the method that is explained, and it's a method that works. And since we are on other operating system, we have a open source version, cross-platform, so VS Code is our best option. So let me just open here a PowerShell session. Okay. So in order to do the remoting is basically the same as we already know. We do an enter PS session, and we specify that our host name in this case is our IP from our Raspberry. So in my case, it's 192.160.190, and our username is Pi, which is the default user. So basically, I'm expecting something here. Nope. Come on. Every single time I've trained this presentation, this was instant. And now it's just hanging here. Let me just... Okay, what am I missing here? Host name, oh, maybe it's this part. No? So you can see that PowerShell here is running. Let's just give it a few seconds. I mean, my IP address is this one, right? Yes, 192.168. Oh no, 168, not 160. Well, on the other times I was using the correct. Yes, that's it. So here we have an error saying from the SSH saying that warning, remote host identification has changed. It's possible that someone is doing something nasty. So we're simply trying to do some debugging, and this already knows that we are trying to do something nasty. Basically what's happening here is that since we've purged and installed a new SSH server, the host identification has changed as it implies. So basically what we have, what we still have is the old credentials or the old keys for the old server. And it's saying like add the correct host key, and in order to do so, run these commands. Basically this will generate a new key pair for our login or our configuration. Sorry, what? Oh, you can see that there's something really buggy sometimes here. This is not perfect yet, but we'll arrange that. So here we are basically sorry, creating a new key pair, saying that our address or our Raspberry Pi address is a known host. So if we try to do the same again, sorry, not this comment, but the enter PS session. It's saying like the authentication host can't be established. Do you trust this one? We do, because we just installed it and we know what we are doing. And I've just typed the password, and now after a few seconds, we should be seeing the remote indication, which is the host name and ps/something. In this case, we have established connection to our Raspberry here. We can do something like lsb release -a to check that we are indeed on our Raspberry. And let's move to the folder that we want to use for debugging. In this case is the folder, cd, is the folder where we have that module. So let's do a print working directory, and we can copy this and say change directory to that one. And we are on that directory. Now the trick here is that if we do some listing here, we can see that, let's say that I will not be debugging the module here because it's kind of hard, and for the purpose that we want here, this simple setup script is enough. So if we do ps edit, this will launch the script or the file in our VS Code, but on the remote session. So if I write here the simple setup.ps1, this, as you can see here, opened me a new window on top, and we have our /temp /remote file /some number /Raspberry Pi. So with this, we are seeing the very same file that is on our Raspberry. We already know this file, which is the one that I've showed you on how to show the letter A. And just before, let me just, damn it, I'll have to run PowerShell again. This is because if you watch the bottom right of your screen, the bottom corner, you will be showing here the letter A. But since I'm already have here some text, I don't want it to be a mess. So I'll do the import module, and after importing, I want to set all the LEDs off. Okay. Let's get back to our scripts. And let's say, for example, that in this case, just as an example, but you want to know how many iterations your index variable had. So you set the breakpoint here, and it's basically the very same old debugging process, which is, as you know, oops, sometimes annoying. So you set the breakpoint, you press F5, you see already the debugging window up there, and our code hits the breakpoint. And after that, we have here a whole set of variables. And I find this somehow annoying, because probably because I'm not really familiar with this, with all the debugging with PowerShell, but last exit code and maxim history count, those are things that are not on my code, and I don't need to know about them. So in this case, what I simply do, even the locals, we have like a lot of things. So basically, as I said, we can add them to the watch, and let's say that I want to know the value of index, and you say like, yes, the index run 3 times, and 3 times because we had 3 registers. And if we continue our debug, if you see on the bottom right after I do this set register, this set register will update all the registers. So basically right now, although it's not lighting up, all the registers already have the values. But when I do the update, all the 3 registers will light up the LEDs. So if I do continue, here we can see all the LEDs that have been lighted up. This pretty much how you can debug a script. So with this, we can just move to our finish line, and we can wrap up what we've been seeing. So I've talked a lot, and if you just woke up, congratulations, you missed a lot of things. And because I'm a cool guy, I'll be showing you what you've just missed. In case you are still awake, congratulations. Hopefully you have learned something new. And this can get you motivated to help me and to help the whole PowerShell community on Raspberry. So basically we've seen is what's a Raspberry Pi. And after that, we've just installed the PowerShell on our Raspberry, which is a really long process. After that, we've jumped to the PowerShell IoT module that relies on the PowerShell. We've seen how that one works by wrapping the Raspberry Pi IO, the Raspberry IO library, which is a .NET library or API, which also wraps the Wiring Pi library. And after that, we've seen my own module that I've started developing that depends on the PowerShell IoT module. Other than that, as we just finished, we've seen how to debug a script, and that's it. So basically, and now as a bonus, you can see something that I've been trying to develop. basically, those are some LED stripes which are known as neopixels by Adafruit. Those are some LEDs that are RGB, and as I told you, you'll be seeing something with the GPIO. If you, I don't know if I can, oh, I don't have here some, okay. If you see on the left, before the first LED, you can see 3 cables. So this uses the GPIO, and you can do something, in this case, after you check my repo, I'll just show you in a second. You can import the module and you simply say set breathing LEDs, and in this case, it will show you these 3 LEDs breathing. You also have an explosion, and basically you define the number of LEDs you want to use, the brightness, the color that you want to have on the left half, the color that you want to have on the right half. You can also specify a color for the explosion. If you don't, it uses the default color, which is also called explosion color or red explosion, something like that. And you define the speed. After you use the configurations, you can pipe that configurations to our set explosion command, and you see something like this. And the most recent one is one that I've done when I was challenged by Tyler, which is one of the folks that developed the IoT module. He might be watching. So basically he challenged me to do something like Morse code on the Raspberry, which is, if you see in the middle where I'm pressing, I have a button there. And if you press once, you send a LED across all the stripe. And if you keep pressing, you see a rainbow color. This was funny because this was a challenge. So it was a bigger pleasure to have done, because, and you know, everyone gets happy after doing some challenge. And basically, just going back just a few slides, if you have in mind, if you still have in mind the configuration, the configuration or the layout on the PowerShell IoT module.
Your audio just fell away. Did you change anything with your microphone?
No. Are you still hearing me?
Yeah, very poorly.
Poorly? I don't know. I think,
okay.
Let me
We'll try Morse code.
Well, I'm almost finishing, so let me. Okay.
Otherwise, shall we open it up to Q&A, see if anyone has any questions?
Yeah, sure. Yes, you can do that.
So does anyone here have a question for Daniel? Then I will relay the question. Yeah.
Is there a reason why Daniel using Windows IoT? Does that gives you PowerShell?
So someone was asking, is there a reason why you're not using Windows IoT Core?
Well, I don't know if, I mean, Windows IoT has the PowerShell already, yes. I don't know if it's the PowerShell Core. And the main reason why I'm not using Windows IoT is because the PowerShell IoT module, I'm not sure, but I think Tyler is here and he might be able to answer that better than me. I think that the IoT module is not fully compatible, if it's anyway compatible with the PowerShell. Sorry, the PowerShell IoT module might not be fully compatible with the Windows IoT. And when I first tried the Windows IoT, I gave it a shot once, and for some reason, after installing it, whenever I tried to open the PowerShell, I typed one letter and everything just froze. So I don't know if I was doing something wrong or not, but I decided to step that back. But no, there's no reason why I'm not using the Windows IoT. I've not tried it. Maybe it works. The project that I was showing you with the LEDs, what I've done was I've basically wrapped a C# library, so that can possibly also work on the IoT one. But then again, I have no reason for not using the Windows IoT module or the Windows IoT version.
Tyler mentioned that it's only supported on Raspbian.
Yeah, that was my idea. So you have the main answer there.
Okay.
Yeah.
Because in this case, this project uses I2C protocol, and the other one, this one that I'm showing now, uses the GPIO. So I heavily rely on the IoT module for the I2C one. So
Yeah, I can actually talk to that. Can you guys hear me?
yep,
we can hear you.
Hello. All right.
Hello.
Hey, everyone. I'm Tyler. I work on the PowerShell team, and I worked on some of this PowerShell IoT business. So just to clarify a little bit, PowerShell Core should work on Windows IoT. I can't say I've tested it much, but I did have someone in my office yesterday testing out the PowerShell Core 6.1.0 Preview 3 that's coming soon, if it's not out already, to work on Windows IoT. So that should work. Now, PowerShell IoT is only supported on Raspbian at the moment. It's possible to add support for Windows IoT, but we just haven't gotten to it yet. But maybe soon.
Okay, thanks for that, Tyler.
Yeah, no worries.
There's more questions, so let's see who's next.
Can PowerShell run also on the Raspberry 2?
The question is, can PowerShell also run on Raspberry 2?
Yes, I do think so, because if I think that the Raspberry 2 has support for the latest version, for the Scratch version. As Tyler mentioned, it only works on the Raspbian, but I think that the module 2 does have the update for the latest module. If so, yes, it should work. In this case, as I mentioned, and as Tyler mentioned also, it works on Raspbian Scratch. So if the module 2 can support the Raspbian Scratch, yes, it should work.
Yeah, and even PowerShell IoT itself, there's a supported platforms section, and that does list Raspberry Pi 2 as well. And I think that's because .NET Core only targets back to Raspberry Pi 2. Anything further back, and you won't have much luck.
Yeah, and you're still waiting for the Raspberry Pi 0W support.
Yeah. It's gonna be good.
Yeah. I don't know. You have more questions yet?
Let's see. Saw people stretching. I'm not sure if there's questions.
Oh, and let me just do a huge special thanks to Adam, who is here by remoting, because as far as I know, this session in his local time it's like 2 a.m. and he said like that's why you have alarm clocks. So I think he just woke up to listen to this. So thank you very much, Adam.
Okay, excellent. Well, then we're going to cut it off here. Thank you very much for your time and coming over remotely to present. And we hope to see you at the next DuPSUG in person. It's only a 2-hour flight, so it should be easy.
Yeah, the flight is not the problem. Thank you very much.
Thank you.
Very nice.
Support from Belgium. There you go. Have a good evening, everyone, and we'll make the recording available later.
Good night.
Thank you very much. Have a good night.
Thanks, everyone. Good night.
Thank you.